Hello everyone, I am Vishal Sorathia, working as an assistant professor in Marwari University, Department of Electronics and Communication Engineering. Today I am going to give you the idea about the memory devices, which is the last chapter of your digital electronics subject. Subject code is 01EC0102. So let's start basic with the first contents, what we are going to be discussing this one. First, in the content, we are going to discuss about the anatomy of the computer, then the basic computer systems, then after that, more specifically about computer memory, and then we are going to discuss about the RAM and ROM. After that, we will going to discuss about that how we can expand our memory and what are the basic block diagram of that. Now, basic anatomy of the computer, in general, we have the three particular unit we have. First, there is a central processing unit, CPU, where CPU will do all the calculations, all the shifting operation, all type of the decision is going to be taken at the CPU. While memory is a one type of the storage device, we will hold the data, and frequently it will do the read and write with the control processing central processing unit. Second, we have the input and output ports. There are the different ports from which we can insert the input or we can display the data out of that. Now this three device is going to be connected with the various type of the bus is there: address bus, data bus, and control bus. Now an address bus which will identify as a basic addresses which is available for your CPU to access their central unit. Generally you are hearing about that you are having the 32-bit processor or 64-bit type of the processor. So that 32 or 64-bit processor is nothing but it's considered as their address capacity of the bus. Where data bus, which is contain the data which is going to be said from the memory and the input output port, and control bus will carry forward the control signal from the input port or from the memory, and it will take the decision accordingly into the CPU unit. Now, by extending the computer system in terms of input and output ports, the input and output ports are like the modem, mouse are there, keyboard is there, removable storage like floppy disk, CD, DVD, where display, monitor, printer, that all considered as a peripheral devices from where we can insert the data or we can display the data. And that what we need to display, what are the data need to display, which is all going to be is going to be controlled by the CPU. So that are the just peripheral devices which will give the data and display the data. Now there is a basic classification of the computer systems are there. So basically 6 computers system in general we can categorize. First of all, there is a mainframe computer. So in mainframe computer you can see over here that in mainframe computer there are the different racks is going to be there, which is connected with the various processor unit, and it's for the specific or some security based application or some more professional application. Mainframe computer is going to be used. Mini computer is going to be used when we required some specific task. For microcomputer, personal computer, that we all know that you have the laptop or desktop, which is considered as a personal computer category. Workstation, sometimes you have observed that workstation is having the it is used for the gaming or for the rendering. So at that application, workstation is going to be used. And supercomputer, which is used when we are having the kind of the some critical computation, some critical task that we will need to carry forward over there. So at that time we require the supercomputers. Now the computer memory is going to be categorized in this 5 stage: CPU register memory, cache memory, RAM, ROM, hard drive, or removable disk. Out of that, this first 3 are the volatile memories. It means it's going to be delete when your power is going to be off. Where the rest of the one, read-only memory and the hard drive, which is a non-volatile memory, which is never going to be deleted even if you have done your power off. Further, this memory is going to be classified in this manner, like initially there is a primary and secondary memory is there. Primary memory contain the cache memory, main memory. In the main memory, two category are there, RAM is there, ROM is there. RAM is also going to be classified as a static RAM, dynamic RAM, where ROM is going to be PROM, EPROM, EEPROM, depend on the different application. Where secondary memory that we can attach externally, which is a magnetic tape, magnetic disk, HDD drive, FTD drive, optical disk like CD, DVD, HVD, Blu-ray disc, flash memory like the memory card, pen drive. So that is how all are the secondary auxiliary memory we have. First of all, we need to start with that. What do you mean by RAM? Now, RAM is the read or write memory where the data can be read from or written into any of the memory location rather than of the any order of which they have arranged. So it can be arranged in any manner, but we can read it in any manner. So RAM is used to store the data, to store the program instruction and the several immediate execution of the program. While at every flash data item is going to be overwrite on the previous one, and it is used for short-term calculation or for the short-term process, and when the power is going to be turned off, the data is going to be deleted, or it cannot retain the data when the power is going to be turned off. Now there is a two type of the RAM. We have dynamic RAM and static RAM. Now dynamic RAM, that's memory is going to be refreshed and it's going to be lose its content whenever it's going to be refreshed. More specifically, that you can see that your PC is having the 4 GB RAM, 16 GB RAM. So that is a kind of the memory capacity which is going to be connected with your computer. And as much the more memory, kind of the more complex computational task you can do that. That's kind of the standard observation we have. Now, in more specifically, that DRAM used a modern system in synchronous DRAM, or it's going to be considered the SDRAM. Generally, you have heard about the DDR3, DDR4, so there are the different kind of the acronym for the DDR as per the requirement of the processor. So in general, that more RAM a device, the faster the performance you can do. This is kind of the basic basic unit cell of the RAM, where the MOSFET capacitor and this row and column is used to assign the data to store in this particular MOSFET. Next, we have the under the RAM category, we have the static RAM. We have in static RAM is used for the system cache memory, and SRAM said to be static because it doesn't need to be refreshed. Like the RAM, it's going to be same. It's not going to be refreshed every time, and it needs to be refreshed thousands of times per second. But it's not going to be never going to be refreshed by ourselves. It's automatically going to be do that. So SRAM is going to be faster than the DRAM, and both are the volatile memory. And this is kind of the standard flip-flop base, or we can say latch base, kind of the basic block diagram or basic circuit diagram is there for the static RAM. Next, we'll start with the ROM. So in the ROM, as I have discussed previously, ROM is going to be type of the memory which is not going to be deleted, and it's going to be stored permanently. And there is another category also we have, like we can read and write or rewrite this ROM again and again depending upon their specification. So once the memory is written in the ROM, it cannot be written into the again. The content of ROM can be accessed via the CPU but cannot be changed by it. There is a one category. Another category we have, we can do the rewritable type of the ROM also, which is available. So in case of the special type of the ROM, that's possible to use, user is going to be do their specific instruction on the particular ROM. Like we can say, if you are having some particular specific task we have, let's take the washing machine. So once you need to fix that, washing machine need to do this task. So according to that program, that memory is going to be written fixed and it's never going to be changed. So it will do some specific task. So such at the time we require the non-programmable ROM. Now different types of the ROM we have. It's PROM, programmable ROM, mask ROM, flash ROM, EPROM, EEPROM, and there are the kind of the detail of that all one. Mask ROM, it's going to be short-term mask read-only memory. It's inexpensive and it's very fast ROM, which is which had hardwired device that contain a pre-programmed set of instruction. Okay, that pre-programmed set of instruction that never going to be changed from the any external user. While in programmable ROM, initially there is a blank memory, but once you have done the program on that, so it's only going to be programmed only first time, and it is during the program during the manufacturing process. Second, we have the erasable programmable read-only memory. Now in EPROM is a special kind of the read-only memory chip that has the opportunity to erase the program data, and that going to be read-only memory to write the data with the high voltage, and data remains until and unless you cannot give the ultraviolet light to that, and it's going to be lasting up to the 10 minutes or the longer. So if such type of the application we have, we can use the EPROM type of the memory. Electrically erasable and programmable read-only memory, similar to that, it's going to be erasable, but not by using the ultraviolet, by using the electrical signal. It's going to be reprogrammed 10,000 times, and therefore its use that use is also going to be flexible when we required some flexible amount of the read and write type of the operation is there. So at the time EEPROM is going to be used. Next is a flash memory, which is going to be programmed kind of the very multiple times. Like you can say in your pen drive, we are having the 51 GB of the pen drive capacity nowadays, and it's going to be having the 10 lakh amount of the cycles of the read write process that is possible with the flash memory. But it's similar to the EEPROM, but the amount of read write cycle is going to be increased a lot. Next, what we need to discuss about that is expanding memory capacity. Consider that previously you have some memory chip is there. Let's take you have the RAM of 16 cross 4. Now what do you mean by this 16 cross 4 we have? We are having kind of the 16 row and 4 column amount of the data that you can store in this particular chip. So 16 bit by 4 bit. So if you want to increase that, previously it's going to be access only 4 bit of data, but if you want to increase it to 4 bit to 8 bit of the expansion of the data, then this is the first expanding memory capacity example is there, in which we can use the word size expansion for this from this one chip. So we are having the RAM 1 is there, RAM 2 is there. So RAM 1 having the size of 16 cross 4 and another having the 16 cross 4, which is RAM 2. Now over here we have the only 4 address buses there, which is going to be applied as a common. Now by applying the extra 2 signal, read and write and chip select, by applying this particular to chip select this pin, we can connect in kind of the simultaneous in manner. And what is going to be happen, like whenever you have select this chip is going to be on, whenever this first chip is going to be on, then it will give the data in D4 to D7. When it's going to be off, or we can say whenever the second chip is also going to be take the data from the D3 to DB. So each and every 4 bit of the IO pin you can connect with the 4 bit of the data bus, and in that manner we can expand our 4 bit data process to the 8 bit data process. But consideration is there, we need to use such a 2 RAM chip which is having the each one of the 4 input IO ports are there. So there is the word size expansion example we have. Second example we have, let's take the memory allocation example. Like in memory allocation example, let's consider that only we are having the 16 cross 8 type of the RAM 1. Second is also going to be 16.8 type of the kind of the memory chip we have. But if you are having the 16 cross 8, it means it is having the 8 bit of the data going to be processed by this RAM. Over here it's also going to be processed with the 8 bit of the data. So over we required 4 address line to handle this particular RAM, because it's 2 raised to 4, it's going to be 16. Similarly we require the 2 raised to 4, so we can say 4 address bit also we require to process this particular chip. Now we are having the address input, if we are increased to 1, if you are increase the address input to 1, then what happen, it's going to be 2 raised to 5, it means it's a 32 address inputs we can work simultaneously by using this 2 particular RAM, and we can give the data of this 32 bit of from the address input to the 8 data bit. But consideration or basic consideration we have, like this 2 RAM chip is going to be work kind of the sequence by sequence. Let's consider if you are having the AB, last address bus is 4 is there, last address bin 4 is going to be 0, then it will enable RAM2 and whatever the data came from the rest of the pin is going to be given at the data bus. Whenever this AB4 is going to be 1, at that time this RAM1 is going to be on, and the data according to that particular address is given to this particular address bus. Now why there is a 1 is going to be on the first chip and 0 is going to be on the second chip, because is a chip select bar is there. So whenever there is a 1, so it's a negative logic. So whenever there is a 1, this chip is going to be on. Whenever there is a 0, this chip is going to be on, and according to that we can access the 2 raised to 5 32 addresses we can access if we are having this such type of the memory location expansion arrangement we have. Now that much of the thing you need to know about these memory devices and how we can use the memory expanding capacity, how we can make it, types of RAM, types of ROM, basic computer architecture, basic peripheral devices, that all stuff we have discussed in this lecture. Thank you for that. For the any query, you can contact me on this given number, and this video is uploaded in the YouTube, so don't forget to like and subscribe this video. Thank you.